Ever looked up at the night sky and wondered what it would be like to call Mars home? It's no longer just science fiction. It's the next great human adventure. Imagine the first Martian city, not of cold steel, but of sprawling, self-sustaining greenhouses. We'd cultivate earthly crops under the crimson sky, creating lush, green oases that produce both food and breathable air. This isn't just about survival, it's about thriving. And the journey home? We'd harness Martian resources, like water ice and carbon dioxide, to create rocket fuel. This process, known as in situ resource utilization, is the key to making humanity a truly multi-planetary species. The red planet isn't just a destination, it's the foundation for our future among the stars. If you're as excited about this as I am, hit that subscribe button and join the journey. Have you ever looked up at the night sky, spotted that tiny red dot, and wondered, what if? What if humanity could build a new home there? Today, we're not just wondering. We're drawing the blueprint for a Martian civilization. This isn't science fiction anymore. It's the next great chapter in human history. So, buckle up as we journey 140 million miles to build a new world. First things first, where do we land? Mars is a planet of extremes. We need a spot that's relatively flat, gets enough sunlight for solar power, and most importantly, has access to water ice. Scientists have identified several prime locations, like the mid-latitudes where vast sheets of subsurface ice lie just a few feet beneath the rusty soil. This ice is our lifeline. It's our drinking water, our breathable air, and a key ingredient for rocket fuel. The initial landing won't be a grand city, but a small, carefully chosen outpost, the seed from which a civilization will grow. Once we've touched down, our first pioneers won't be living in sprawling mansions. Their initial homes will likely be the landers themselves, or inflatable habitats brought from Earth. But these are temporary. The real challenge is building permanent, radiation-shielded structures. Mars lacks a thick atmosphere and a global magnetic field, leaving its surface exposed to harsh solar and cosmic radiation. The solution? Go underground. We can use semi-autonomous rovers to dig into the Martian soil, or regolith, creating subterranean habitats. We could also 3D print structures using the regolith itself, mixing it with a binding polymer to create a Martian concrete. Imagine homes built inside lava tubes, natural underground tunnels formed by ancient volcanic flows, providing instant massive scale protection. These first Martian homes will be cozy, functional, and above all, safe. With shelter secured, the next priority is food and air. We can't ship everything from Earth. That's just not sustainable. The key is creating a self-sufficient, closed-loop ecosystem. This is where Martian greenhouses come in. These won't be your average backyard sheds. They'll be highly advanced, pressurized biodomes. Inside, under arrays of full-spectrum LED lights, we'll use hydroponics and aeroponics to grow crops. Think leafy greens, potatoes, soybeans, and tomatoes, nutrient-dense and fast-growing. The plants will do double duty. They'll produce food and, through photosynthesis, convert the carbon dioxide exhaled by astronauts into the precious oxygen we need to breathe. Every drop of water, every bit of waste will be recycled and reused. Nothing goes to waste on Mars. It's the ultimate lesson in sustainability. Life on Mars won't be all work and no play. A thriving civilization needs a society. It needs culture, community, and a sense of purpose beyond mere survival. As the outpost grows, we'll see the development of communal spaces, labs for research, and recreational areas. Maybe even a low-gravity gymnasium, where you could jump 3 times higher than on Earth. Early Martian society will be a unique blend of scientists, engineers, and technicians, all bound by a shared, incredible mission. The challenges they face will forge unbreakable bonds. Every success, from the first successful harvest to the birth of the first Martian-born human, will be a celebration for all of humanity. But how do we sustain this city? And crucially, how do we ever get back? The answer, once again, lies in the Martian environment itself. The Martian atmosphere is over 95% carbon dioxide. Using a process called the Sabatier reaction, we can combine this atmospheric CO2 with hydrogen brought from Earth or electrolyzed from Martian water ice. The result? Methane and water. The water gets recycled and the methane. That's our rocket fuel. This is the game changer, known as in situ resource utilization, or ISRU. We'll essentially be living off the land and manufacturing our own return ticket right there on Mars. We can build propellant depots, refueling stations for ships making the long journey back to Earth, or venturing even deeper into the solar system. With a sustainable source of fuel, our Martian city transforms from a remote outpost into a true interplanetary hub. It becomes a base for asteroid mining, a stepping stone to Jupiter's moons, and a scientific wonderland. We could build telescopes on Mars that, free from Earth's atmospheric distortion, would give us the clearest views of the universe we've ever had. We'd study Martian geology to better understand the history of our own planet and search for signs of past or even present life beneath the surface. The scientific discoveries made on Mars could redefine our understanding of our place in the cosmos. As decades turn into centuries, the Martian civilization will evolve. The initial underground habitats will expand into vast, interconnected cities. Perhaps, through a long, ambitious process of terraforming, we could even thicken the atmosphere and warm the planet, eventually allowing liquid water to flow on the surface once more. Imagine a distant future where our descendants can walk on the surface of a green and blue Mars, looking up at the sky to see a pale blue dot called Earth, their ancestral home. This isn't just a dream. It's a blueprint built on science, engineering, and the unyielding human spirit of exploration. Building a civilization on Mars will be the hardest thing we've ever done. It will test our technology, our resolve, and our ability to work together as a species. But the journey to that red planet is also a journey to discovering the best in ourselves. It's a plan for a backup, a hope for the future, and a testament to our endless curiosity. Thank you so much for joining me on this incredible journey to Mars. What part of building a Martian city excites you the most? Let me know in the comments below. And if you love exploring big ideas about the future of humanity, make sure to like this video and subscribe for more adventures. See you in the next one.